So good morning. So next topic is sedimentation aided with coagulation. Okay. So in previous topic plain sedimentation matanda பார்த்தோம். So plain sedimentation na chemical will not be added to enhance the coagulant. Okay. To enhance the flocculation, to enhance the sedimentation, a coagulant is not added in the water. Okay. So in this type, apart from the plain sedimentation, that is a type 1 sedimentation, it is used to remove the suspended particles from the water without adding any chemicals. Okay. So very fine suspended mud and the colloidal matters வந்து எப்படி remove பண்ணுவாங்க அப்படின்னா, we have to increase the specific gravity of the colloidal particles by adding chemicals. Okay. So in order to increase the size and specific gravity, we make them to settle. So we are going to use some chemicals in that. Okay, the special chemicals which are added to the water in order to increase the size and specific gravity of the very fine suspended particles, or the name வந்து coagulant. Okay, a chemical added to the water to increase the size and specific gravity of the suspended colloidal particles. In the suspended colloidal particles in the water, this chemical is called as an coagulant. Okay, the precipitate formed after adding the chemical or a coagulation, the process is called as flocculation. Okay, flock. So what happens if a chemical is added? The water is mixed using a blade with a particular speed for 30 minutes, and after that it will be continuously, or it will be increasing and decreasing the speed. The flock will be formulated. Okay, this is called as a flock. A very fine colloidal particles present in the water get attracted and absorbed by these flocks, forming bigger size flocculated particles and settle down easily. So what happens? So when the chemical is added, a flock is created. That flock will attract the colloidal particles, colloidal impurities from the water. It makes maybe bigger in size. It increases the specific gravity, and then it will settle down. Okay. So the chemicals used for coagulants are, so alum is the very cheap and best chemical still now we are used in the water treatment plant. Apart from alum, we are using iron salts like ferrous sulfide, ferric chloride are used as a coagulants. So alum, aluminium sulfate, okay, Al2SO4 to 18 times of H2O. Okay, so aluminium sulfate is the chemical name for alum. So when alum is added in the water, it reacts with bicarbonate alkalides. Okay, bicarbonate alkalide soda. It will react and form a flock of aluminium hydroxide. The flock is alum. Alum வந்து யூஸ் பண்ணும்போது the flock name வந்து aluminium hydroxide. Okay, the flock attracts other fine particles and suspended matter, and thus grow in size and finally settle down at the bottom of the tank. இதான் அதோட concept. Okay, so what happens when alum is added with biocarb, that is bicarbonate alkali, that is calcium bicarbonate. Okay, what happens? This calcium sulfate from aluminium hydroxide will be formed. Okay, so this arrow mark indicates it will settle down at the bottom, plus it will releases the carbon dioxide, that is a gas, is goes to the atmosphere. Okay, so what happens when alum is reacted with the bicarbonate salts of calcium, it will gives calcium sulfate and aluminium hydroxide. This aluminium hydroxide is a flock. Okay, so after that, the addition of alum to the water creates permanent hardness to the water in the form of calcium sulfate. So you know that hardness created by sulfates salts. Okay, so calcium sulfate, it creates a hardness. Okay, so the liberation of carbon dioxide gas causes corrosion to the tanks. So the addition of alum to the water creates a permanent hardness, and gases it causes corrosion. Okay, so the dose of alum may vary from 5 mg per liter for clear water to 85 mg per liter for highly turbid water. Okay. So the average dosage for this 17 mg per liter. So how they find the dosage of water, dosage of alum in water by jar test apparatus. Okay, jar test is used. So they take the water and they are supplied with various grams of alum for each jar. Okay, 6 jars actually will be there, and each jar they can increases the dosage of alum by 2 ml, 4 ml, 6 ml, 8 ml அப்படின்னு சொல்லிட்டு they are providing the alum in that one, and they are allowed to flocculate, flock create ஆயிட்டு it will create a, it will make the colloidal particles to settle down. Okay, so it வந்து normal average dosage கொடுத்திருக்காங்க. But in every day in water treatment plant, the alum dosage will be decided by a jar test only. Okay, so normally based upon the quality of the turbidity in the water, it will be decided. So it is an effective coagulant, and it's now throughout the world we are using alum as a coagulant in water treatment. Okay, so why abdina? It is quite cheap. Okay, excellent stable flock and does not require any skilled labor and supervision for handling. So that is the main important. It is cheap and best also. Okay, so the main problem is dispose the sludge formed and found to be unsuitable for filling in low lying land. So என்ன ஆகும், the sludge வருதுல்ல, the waste collected, that is not suitable to filling in the land, so it will be, it should not be disposed in the land. So the another thing is the flock created a stable flock. Stable flock அப்படின்னும் போது it will not dissolve again with the minimum pressure or minimum shaking. Okay, that is the point. So but the disadvantage is that it should not be disposed into a land. But the recent research shows that the recovery of alum from the sludge is possible if it is reused for coagulation. So what happens, what the research is going on and what the research will be means, the alum திருப்பியும் அந்த water sludge ல இருந்து பிரிச்சு எடுக்க முடியும். Okay, we can again recover the alum from the sludge, and it be used as a coagulant. So same alum we are used as a coagulant, and if this water is again disposed of in land or some other vegetation and some other uses. Okay, that's only turbid water, it does not contain any bacteria or fungi. So just it is disposed in the, or it is used for some other purposes. Okay, so again alum பிரிச்செடுத்து we can use in the treatment plant. Okay, so next one the copperous or ferrous sulfate. So this is again a coagulant. Okay, so alum is a worldwide used one. So this is ferrous FeSO4 7 times of HO2, that is ferrous sulfate. Okay, having a chemical formula of this, it is generally added with lime for coagulation process. So it is generally added with lime. Lime is calcium oxide, calcium oxide. Okay, so that is CaO, that is a lime. Okay, the lime is added either to copperas or vice versa. Okay, so either lime is added to the copperas or copperas is added to the lime. When lime is added first, the following reaction will take place. So CaO is not stable. So when it react with water, it will be converted to calcium hydroxide. Okay, that quick lime is converted to a lime. Okay. So copper is FeSO4 7 times of H2O plus hydrated lime. So that is called as hydrated lime. Okay, normal lime is the CaO, calcium oxide. When it is added with water, that calcium oxide is converted to calcium hydroxide. Okay, that is called as an hydrated lime. Okay, hydrated is nothing but the water is added in the lime so that the chemical reaction will take place and the calcium oxide is converted into calcium hydroxide. So again we can get a calcium sulfate plus ferrous hydroxide plus water will be separated. So this is the reaction taken place in the, when ferrous sulfate is added with the water. So what happens, that calcium sulfate will be again a hardness created in the water, that is a calcium sulfate hardness plus ferrous hydroxide plus 7 times of H2O. Okay. So when copper is added earlier to the lime, the reaction takes place. So what happened, when ferrous sulfate plus, when the copper is added earlier before the lime is added, so what happens, the alkali present in the raw water, that is calcium hydrocarbonate. It ferrous hydrocarbonate plus CaCO4, calcium carbonate plus 7 times of H2O. Okay, and then when this ferrous hydrocarbonate plus 2 times of hydrated lime. Okay, first when the copperus is added, that copperus reacted with the alkali in the raw water and converts to a ferrous hydroxide. That is, this ferrous bicarbonate react with the calcium hydroxide to form a ferrous hydroxide plus calcium carbonate plus water. So this plus ferrous hydroxide formed in either case. So this ferrous hydroxide converts into oxidized and converts into ferric hydroxide, that is a precipitate. So either in both the cases, okay, the ferrous hydroxide react with the oxygen and in the water and forms a ferric hydroxide, that is the flock, that is the precipitate in this when copperus is added in the water. Okay, the ferric hydroxide forms the flock and thus helps in sedimentation. Okay, so this is the second one. First one alum, second one copperus. Okay. Chlorinated copperus. So chlorine is a disinfection. So it is chlorine is a, if alum வந்து எப்படி வேர்ல்டு வைடா வந்து we are used as a coagulant அப்படின்னு யூஸ் பண்றோமோ, same thing chlorine வந்து is one of a cheap and best disinfectant that is used in the water treatment plant. So chlorinated copperus is a solution of copperus or ferrous sulfate that chlorine is added to a solution of copperus. So chlorine என்னது we are using நார்மலாவே chlorine நம்ம எங்க யூஸ் பண்ணுவோம், we are using the disinfectant unit and used for a cleaner, all those things we are using chlorine. When chlorine is added with the ferrous sulfate, they react and forms ferric sulfate. Okay, and ferric chloride, ferric sulfate ஆகவும் ferric chloride ஆகவும் it will be turns to. Okay, so this ferric sulfate and ferric chloride is known as chlorinated copperus and it is a valuable coagulant for removing color. So it removes the colors also. Okay, so this ferric sulfate react with hydrated lime to cause calcium sulfate plus ferric hydroxide precipitate. Okay, so this calcium sulfate and ferric hydroxide precipitate. Okay, so this ferric chloride, so this ferric chloride plus hydrated lime. Okay, so the ferric chloride plus hydrated lime, it again converts to ca- calcium chloride plus ferric hydroxide precipitate. Okay, so this ferric hydroxide is act as a flock and this flock is attracts the colloidal particles from the water and again it acts as a very good coagulant. Okay, so first one we are seeing alum, second one copperus, and third one chlorinated copperus. So chlorinated copperus we are the reaction takes place is ferric sulfate and ferric chloride. Okay, these ferric sulfate and ferric chloride reacts with the lime, hydrated lime in the water, hydrated lime what we are provided and converts to ferric hydroxide precipitate. Okay, so again calcium sulfate and calcium chloride is a hardness. Okay, the salt is a hardness in the water. The result ferric hydroxide forms the flock and helps in sedimentation. Okay, sodium aluminate, it is another good coagulant. Okay, so apart from alum and iron salts, sodium aluminate, okay, sorry, it is aluminate. Sodium aluminate is also used as a coagulant. Okay, so how it is used is sodium aluminate Na2Al2O4. Okay, so this is used as a coagulant. Okay, so the chemical when dissolved and mixed with water react with salt of. Okay, the chemical when dissolved and mixed with water react with the salt of calcium and magnesium present in the water result in the formation of calcium or magnesium aluminate. Okay. So what happens when sodium aluminate plus calcium bicarbonate converts to calcium aluminate? So calcium aluminate is a precipitate in the water. So this calcium aluminate again attracts the flock and it converts the it attracts the flock and converts the water to the purest form that the flock will settle down. The coagulant will settle down. Okay. So this cost is about 1.5 times more than the alum and therefore avoided for treating ordinary public water supplies. Okay. So it will be costly. So based on this, it will be normally it is not used. Okay. So this chemical is reduces the temporary and permanent hardness present in the water. So hence it is used in treatment of boilers. Okay, in boilers to remove the hardness, this chemical is mostly used, but not in the public water supplies. Okay. So chemicals applied for water treatment அப்படின்றது so factors, so alum and coagulant where it is mostly used. So it is alum is most usually in water treatment plant, and in wastewater treatment the iron salts are commonly used. Okay. So flocculation is moderate in alum. So in waste normal water a medium flock is enough, but in iron salts it will be heavy flock. Okay. And then removal of odor and taste removes a little taste and odor from the water. Okay. And here it removes H2S and then taste and color removal will be high. Corrosive, no, it not impacts the corrosiveness to water. It impacts more corrosiveness to the water. So due to the iron present in that, it will enhance the corrosion. Okay. Handling and supervision. So for alum, we don't need not, much supervision and skilled laborers are not required. But in handling of iron salts, a skilled labor will be required because it tends to corrosive. Okay. Bacterial growth is not occurs normally in alum, but it promotes the growth of iron bacteria in the distribution system. Okay. So pH range 6.5 to 8.3, and here it is 4 to 8.5. Okay. So what are the advantages and disadvantages of alum and iron salts? So iron salts produce heavy flock and therefore it remove much more suspended matter than the alum. The alum iron salts we get more. Okay. So iron salts being good oxidizing agent can remove hydrogen sulfide and its corresponding taste in order from the water. So iron salts has a wide variety range of pH value. So iron salts என்ன ஆகும்? Cast stain, okay, because of the iron, and promotes the iron bacteria in the distribution system. More corrosiveness, handling and storage of iron salts will require a skilled person to. Okay. So iron salts are most used in sewage treatment, and alum is most commonly used in water treatment. So now we are going to see what are the constituents of coagulation sedimentation tank. Okay. So just simply a sedimentation tank means it its arrangement will be an inlet pipe with a baffle wall. Water enters to a slush removal will be there, and a effluent the outlet pipe will be there. But now the constituents of this coagulation cum sedimentation tank is we want a feeding device. So feeding device is used to feed the coagulant into the water, that is alum or a iron salt or a copperas, whatever it may be. If we are going to feed it, we need a feeding device, a mixing basin. So coagulant may be added in a wet dry form or in a solution form. Okay. If you are added the coagulant in a solution form, yeah, make the coagulant into a solution. Okay. So that solution is we can get by a mixing basin and flocculation tank. So flocculation tank, blades are arranged in that to create a flock first of all. Okay. So after the flocculation tank, so after the flock is created, what happens? It attracts the particles and it will settle down. So at last there will be a sedimentation tank. So these are the major constituents of the coagulation comes sedimentation tank. So it is not only a sedimentation tank, coagulation is also in this. Okay. So what we need? a feeding device, a mixing basin, a flocculation tank, and a sedimentation tank. Okay. So initially the chemical coagulant is fed either in a dry or solution form in a raw water through the feeding device. Okay. After that the mixture is mixed with the mixing basin and a flock is created. That flock is allowed to the flocculation tank. It finally passes to sedimentation tank where with the particle get removed. Okay. So it helps to remove the turbidity in 10 to 20 mg per liter. So it may also help in reducing the bacteria from the water. It reduces the B. coli index bacteria. That is the bacteria cause the various water-borne diseases like the diarrhea and typhoid. So that is the bacteria. So it will be removed by this treatment. Okay. So this is the arrangement of the clariflocculator. Okay. So first the water is enters to. So after it is entered, so here the mixer will be there here. So it mixed up. So it in this inlet, the solution will be applied and the solution is mixed in this way. And here the blades are the flocculators are here. So these flocculators will mixed up water in this one and it will settle down. So after that slowly it will goes to the sedimentation tank. So this is circular feed one and this circular feed one the sludges are removed and the effluent will goes to the next one. So inlet and a mixer will be here and this blades are used to create a flock and after that it gets into the settling tank and this is effluent to the next unit. Okay. So from sedimentation to the disinfection or the filtration unit. Okay. Next will be the filtration. Okay. So this feeding device we already explained based upon the characteristic of the coagulant. Based on the cost of the coagulant, it may be a dry form or in a wet form will be decided. So this is a feeding device. So here again a blade arrangement will be here. So this is for having a mixing basin that is so agitating plates are here. These agitating plates are used to mix the solution well. Okay, like just shaking the agitating plates like we are using cement concrete use பண்ணுவோம்ல just a vibrator. Okay, like this. A hopper, a powder coagulant will be here, and a driving pulley it is used to distribute that is solution evenly through the mixing basin. Okay, this is normal arrangement, either this type or in this type. Okay, and dry feeding device and wet feeding. This is a wet feeding device. In this wet feeding device, a pulley is here and here a coagulant head, the coagulant feeding tank. Okay, a ball valve is here. It is used to indicate the level of the water in that pond. A conical plug is there. It is used to control the flow of the water get into the get it into the coagulant get it to the water. Okay, so this is a mixing basin and it is a float. This is a float chamber. This is used to indicate again. It is used to indicate whether how much of coagulant is to be released from this pulley. Okay. So this is the working of the conical plug. So this is again a mixing basin with the baffle walls. So why this baffle walls are provided means it again created the flock in a better way. At direction of the water will be uh, changed so that the velocity will be increased. So that we are just creating a flock. So in this is the plan. So water is enters. This is the inlet and this is the flow of water. Okay, it will be the flow of water and again it is effluent will be get out. So this is the type of a mixing basin. Again, it is used in the water treatment plant. Okay. So this is again this is the proper thing. So electronic motor will be there. This is a impeller or a fan unit that is used to create a flock. So these are the various types of mechanical arrangement that is used in the water treatment plant. Okay. So coagulant pipe and feeding device are provided. So this is raw water to the flocculation fan like arrangement to create a flock. Okay.